Today we'll be discussing the LeetCode problem of the day, compare version numbers. In this question, we are given two version strings, version 1 and version 2, and we just have to compare them. So a version string consists of revisions separated by dots, and the value of the revision is its integer conversion ignoring leading zeros. For example, if we have a string like this, 7 dot 0 2 dot 1 1 dot 0 0 1. So this string basically means that the version 7 and then the next version is 2, then 1 1 and then 1. So whatever the versions we have, we just ignore the leading zeros and then we take the integer value of the versions. So this string is denoting the version something like this, 7.2.11.1. And when we compare the two strings, two versions, version 1 and version 2, we have to compare them from left to right order. And while comparing, if any one of the version string has a smaller value, then that version is less than the other version. And also while we compare, if the version exhausts, I mean, suppose we have another version like this, 7.2.9. So the version just stops here, but in this we have like 4 places, 7, 2, 11 and 1. So we consider the extra as zeros. So we just pad the missing value, missing divisions with 0. And if the version 1 is less than version 2, we have to written -1. If version 1 is greater than version 2, written 1. If otherwise, if both are equal, we just have to written 0. So let's look at the examples to understand the question better. So the first example is version 1.2 and 1.10. So we have 1.2 and we have 1.10. So this number is first is 1 and then point and the next is 2. This number can be treated as 1 point and then the next number is 10. Now we first check the I'll just write it beneath it. So we just check the first position. So both are equal, so we move to the next position. When we move to the next position, we see that in the version 2 we have a greater value, so that means version 2 is greater than version 1. So we written -1 because version 2 is greater than version 1. Now coming to the next example, we have 1.0.1, which can be written as 1.1 because 01 is treated as 1 only. And again, this 1.001 can also be treated as 1.1 because we ignore the leading zeros. So we can see that both the versions are same, so we return 0. Now coming to the third example, the first number is 1.0 and the second version is 1.0.0.0. So in the first version, it just stopped after 1 dot, so we can just add it with zeros to match the size of the second version. And once we do this, we just compare both these versions. And in this case, both are equal, so we return 0. So these are the 3 inputs in the question. I've also added some more inputs to understand the question even more better. So the fourth input is 1.0.1. In that, the first version is this and the second version is just 1, and we add it with the leading zeros and trailing zeros, 1.0.0. Now we check both of them. So the first position, both are same. The second position, both are same. While we check the third position, we see that in this we have 1 which is greater than 0. So that means version 1 is greater than version 2. Now moving to the next input, we have 75 dot, this 05 is treated as 5 only, and then we have 2 and 4, and the version 2 is 75 dot 005 is treated as 5, and we have 3, and the number ends, so we can just put a 0 at the end. Now when we compare these two, first is equal, both 75, second also equal. In the third, we have this 3 greater than 2, so that means version 2 is greater than version 1. And coming to the final input, we have 0.1 for the first for the version 1, and version 2 string we have 1.1. So clearly we can see that in the first number itself version 2 is greater, so we just written -1. Now coming to the approach, what we can do is let me just take an example. This one, the first string is 72.05.2.4, and the second string is 72.005.3. So the approach is straightforward, but like we check the numbers from left to right. So first we start here, we just take a pointer I equal to here and another pointer j equal to here, and once we are at the starting, we just move this I until we reach a dot, and we compute what is the value here. So initially my number will be 0. So first I will encounter 7. So what I'll do is I'll just add this 7 in this number, and I'll use the formula number equal to number into 10 plus this 7. So what this does is, first number is 0, so it puts a 0 and then adds 7. So initially from 0 this will become 7. Now we move the I to 2. Now we have to add 2 to this 7, but before adding 2 we just multiply 7 by 10, so that it makes it 70, and then when we add 2 it will become 72. So this is how we are just forming the number each digit by digit, and once we reach the dot we stop. So 72 is the first number. Similarly, we take another variable and we repeat the same thing for j as well. So for j also we will reach 72, and now once we got both the numbers, we will just compare it. If number 1 is greater than number 2, then that means version 1 is greater than version 2, so we return 1. If otherwise, if number 2 is greater than number 1, we return -1. If both are same, then we don't do anything, we just continue to the next numbers. So currently my I is here, my j is here. So if both the numbers are same, I'll just move my I here, and I'll also move my j here and continue to do the same process again. So in the next step, again, my I is at here, and it will move until it encounters a dot, and it will, in the process, it will compute this value. So initially it is 0. So 0 into 0 plus 0 is 0. And then after that, 0 into 0 plus 5. So this will become 5. And for the second number, initially it's 0. It becomes 0 into 0 plus 0, 0. Again into 0 plus 0, 0. And again into 0 plus 5, it becomes 5. So again, we can see both numbers are same. So we just move I and j to the next pointers. So I will be here, j will be here. Now again, I will compute the next number. So for this, the number will be 2, and for this version 2, the number will be 3. So here we can see that we have a number mismatch. So version 2 number is greater than version 1 number. That means version 2 is greater than version 1. So we directly return -1, and we just end our function. Suppose, let's say that this number is also equal, 3. So since both are equal, we just do I++ and j++. But once we do this, we can see that this j is out of bound of this string. So that means it is considered as zeros. So what we can do is we can iterate on the first string, which is not exhausted completely, and just check if my numbers is not 0 or not. If it's any number which is greater than 0, that means this version is greater than this version 2. If this was 0, then again it will check both are equal, and then it will move forward, and at the end it will just return that both the versions are same. Now let's quickly go over the code. So first let me take two variables which will be pointers. I will be pointing on version 1 and J will be pointing on version 2, initially at index zeros. So condition while I less than version 1 dot length and J less than version 2 dot length. So now we want to, like, initially both I and J are here. We want to iterate till we find a dot and we want to compute a number. So what we can do is, while version 1 dot char at I not equal to a dot, while we until we find a dot, we just keep increasing it. And also before doing this, we just have to check the boundary condition as well, because at any point it can go out of bound. So my I is in the range and then my character is not equal to a dot, then we increase it. And while we increase it, we should also compute the number. For that, I'll just take num1. So what I'll do is num1 equal to num1 into 10 plus this version 1 dot char at I minus 0. So this will do the subtraction in ASCII, and it will just give us the required digit. Digit 5 minus digit 0 will give you 5. So that's what we want. And once this loop is finished, that means we have reached a dot, or we have reached the end, and we have computed our number 1. So similarly, let's do it for num2 as well. Num2 equal to 0. And let me change it to num2. And this as version 2. Version 2. And I will be J. And then J++. So what this does is, when both of the loops end, I will be pointing at this dot and J will be pointing at this dot. Now what we do is, we just check, we just compare both num1 and num2. So if num1 is greater than num2, then we can simply return 1, because if version 1 is greater than version 2, we return 1. Else if num1 is less than num2, we return -1. Else in the sense both num1 and num2 are same, so that means we just have to proceed to the next number. So we just do I++ and then J++. So this is the loop which will check all the numbers until one of them exhausted the boundary, or both of them exhausted the boundary. So if both of them exhausted the boundary, then we can just simply return 0. That means the numbers are same for all the digits. But there's also a case where, suppose version 1 went out of bound. Let's see, in this case only, we can see that version 2, after processing this 3, let's say this is also equal to 2. Now after processing this 2, this version 2 will go out of bound. So we just are left with this version 1, and we just have to check this one. So let's check for version 1 first. So for the condition, so the condition is, we check for the version 1 till that is also exhausted, while I less than version 1 dot length. Here we will just check if my character is not 0. So what I mean is, version 1 dot char at I if it's not equal to 0, then we return 1. If it's not equal to 0, that means we found a number which is greater, because here it's always 0, because we add zeros if it's shorter than the other version. So if it's not a 0, we can simply say that we return 1. And also we need to take care of the character when it's a dot. And also it's not a dot. If it's a dot, we just have to keep moving forward. And then I++. So this while loop is case when version 2 exhausted first. Now let's similarly look at the case when version 1 exhausts first. So when version 1 is exhausted, we just have to iterate on version 2 and see whether any of the characters are not 0 or not, and then return -1 in this case. And this will be j++. And while j less than version and version 2. Let me just comment these examples and test it. Okay. Caret. Looks like I'm coding it in C++. Let me quickly change it to Python. Not Python, Java. Okay, we can paste the entire thing. Yeah. In Java, we have S in capital. Yeah, and let me submit. Finally, coming to the time and space complexity analysis. So for the time complexity, we have a while loop, and in that we also have another while loop. This looks like it's nested, but overall it runs from I equal to 1 to length, version 1 dot length, and I from 0 to version 1 dot length, and j from 0 to version 2 dot length. So in total, this loop will run just the length of version 1 plus version 2. And again, we have this while loop, and at max this can run order of n times the version 1 length. Similarly, this can run order of n times. So overall, time complexity will be order of n. And space complexity will be constant, because the only variables we have initialized is I, j, num1 and num2. So space complexity will be order of 1. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.